Data reduction. What is data reduction? Data reduction is a capacity optimization technique, in which data is reduced to its simplest possible form, to free up capacity on a storage device. There are many ways to reduce data, but the idea is very simple: squeeze as much data into physical storage as possible, to maximize capacity. Data reduction does not make sense by itself, unless it is associated with a certain purpose. The purpose in turn dictates the requirements for the corresponding data reduction techniques. A naive purpose for data reduction is to reduce the storage space. This requires a technique to compress the data into a more compact format, and also to restore the original data when the data needs to be examined. Nowadays, storage space may not be the primary concern, and the needs for data reduction come frequently from database applications. In this case, the purpose for data reduction is to save computational cost, or disk access cost in query processing. Benefits of data reduction. The main benefit of data reduction is pretty straightforward. The more data you can fit into a terabyte of disk space, the less capacity you'll need to purchase. Data reduction can 1. Save energy. 2. Reduce your physical storage costs. 3. Decrease your data center footprint. Data reduction greatly increases the efficiency of a storage system, and directly impacts your total spend on capacity. There are two primary methods of data reduction: 1. Dimensionality reduction. 2. Numerosity reduction. Dimensionality reduction. Dimensionality reduction is the process of reducing the number of dimensions the data is spread across. It means the attributes or features that the dataset carries as the number of dimensions increases the sparsity. This sparsity is critical to clustering, outlier analysis, and other algorithms. With reduced dimensionality, it is easy to visualize and manipulate data. There are three types of dimensionality reduction. There are mainly three ways used in dimensionality reduction. 1. Wavelet Transform. 2. Principal component analysis. 3. Attribute subset selection. 1. Wavelet Transform. Wavelet Transform is a lossy method for dimensionality reduction, where a data vector x is transformed into another vector x, in such a way that both x and x still represent the same length. The result of wavelet transform can be truncated, unlike its original, thus achieving dimensionality reduction. Wavelet transforms are well suited for data cube, sparse data, or data which is highly skewed. Wavelet transform is often used in image compression. Two. Principal component analysis. This method involves the identification of a few independent tuples with in attributes that can represent the entire dataset. This method can be applied to skewed and sparse data. 3. Attribute subset selection. Here, attributes are relevant to data mining, or redundant ones are not included, in a core attribute subset. The core attribute subset selection reduces the data volume and dimensionality. B. Numerosity reduction. This method uses alternate, small forms of data representation, thus reducing data volume. There are two types of numerosity reduction: 1. Parametric. 2. Non-parametric. 1. Parametric. This method assumes a model into which the data fits. Data model parameters are estimated, and only those parameters are stored, and the rest of the data is discarded. For example, a regression model can be used to achieve parametric reduction if the data fits the linear regression model. Linear regression models, a linear relationship between two attributes of the dataset. Let's say we need to fit a linear regression model between two attributes, x and y, where y is the dependent attribute, and x is the independent attribute, or predictor attribute. The model can be represented by the equation y equals wx plus b, where w and b are regression coefficients. A multiple linear regression model lets us express the attribute y in terms of multiple predictor attributes. Another method, the log linear model, discovers the relationship between two or more discrete attributes. Assume we have a set of tuples in n-dimensional space. The log linear model helps to derive the probability of each tuple in this n-dimensional space. Two, non-parametric. A non-parametric numerosity reduction technique does not assume any model. The non-parametric technique results in a more uniform reduction, irrespective of data size, but it may not achieve a high volume of data reduction like the parametric one. There are at least 4 types of non-parametric data reduction techniques: histogram, clustering, sampling, data cube aggregation, data compression. C. Histogram. A histogram can be used to represent dense, sparse, skewed or uniform data, involving multiple attributes, effectively up to 5 together. D. Clustering. In clustering, the dataset is replaced by the cluster representation, where the data is split between clusters, depending on similarities to each other within cluster, and dissimilarities to other clusters. The more the similarity within cluster, the closer they appear within the cluster. The quality of the cluster depends on the maximum distance between any 2 data items in the cluster. E. Sampling. Sampling is capable of reducing large dataset into smaller sample datasets, reducing it to a representation of the original dataset. There are 4 types of sampling data reduction methods. 1. Simple random sample without replacement of sizes. 2. Simple random sample with replacement of sizes. 3. Cluster sample. 4. Stratified sample. F. Data cube aggregation. Data cube aggregation is a multidimensional aggregation that uses aggregation at various levels of a data cube to represent the original dataset, thus achieving data reduction. Data cube aggregation, where the data cube is a much more efficient way of storing data, thus achieving data reduction, besides faster aggregation operations. G. Data compression. It employs modification, encoding, or converting the structure of data in a way that consumes less space. Data compression involves building a compact representation of information by removing redundancy and representing data in binary form. Data that can be restored successfully from its compressed form is called lossless compression, while the opposite, where it is not possible to restore the original form from the compressed form, is lossy compression.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.